today. Dr. Syahrul Fithry bin Senin has started his career as academician at UiTM Penang since 2004. A graduate of University Malaya, he started his career by involving in structural and civil engineering consultancy works in the year of 1997. Currently, he is actively involved in using MATLAB and GNU Octave for his numerical method-related research work and also lectures. His focus area of research are in artificial neural network, deep learning for structural damage or defect recognition and prediction. His knowledge is applied to the non-destructive structural defect assessment data from building inspection work by the radar signal from the electromagnetic wave sensors such as ground penetrating radar and others related sensors. He is also a professional technologist in building and construction field and actively involved in with Malaysian Board of Technologists and Board. Hence, without further ado, please give your attention to technologist Syahrul Fithry bin Senin. Assalamualaikum, sir. How are you?
Waalaikumsalam to the moderator itself. Hopefully all of us here are healthy and in wellness. I just want to welcome to also the lecturers who are joining this webinar, as well as also the students who are interested to know something about the new era of research, where using the artificial neural network, or some people link it with the machine learning or artificial intelligence with the research work, and also in the civil engineering research activities after you graduated. Okay, so can I start now, or you want to?
Yeah, because I think this topic is very interesting and our audience is eager to know more about it. Maybe you can start now.
Okay, thank you. Okay, disclaimer. I'm not 100% expert in this field, but I started with this field since 2015, 2016 until now. So I have some knowledge that I can share with you. So I'm still learning with the research work dealing with this artificial neural network, and hopefully all of you can understand what is the current state of this knowledge, how it's being developed from my experience until I apply it to my research work, and what is the future direction of this technology, because we will live with this technology until another 1 decade, because this technology will be evolved and also transforming. So allow me to share my slides. Okay, just to confirm from with the moderator, can you see my computer screen now?
Yes.
Okay, thank you. Okay, sorry for the, where is the button? Okay. So the topic that I want to share with all of us today, about 2 hours, is the potentials of applications of this new knowledge, which is called as the artificial intelligence. In the previous topic, it should be A and N, but I want to take the scope much more general so that we can understand from the roots of the knowledge, which is the artificial intelligence. Most of us, we call it as AI. And this application, I want to focus only in the civil engineering activities as a practicing engineer and also as academician in our research works. So I covered both so that we can have a total overview of the knowledge. And I'm coming from UiTM Pulau Pinang in the campus of Permatang Pau. I'm a senior lecturer at the university and doing research and also teaching in the structural engineering divisions. Okay, so this is the content more or less will be covered during these 2 hours. We will start something with the introduction to the artificial intelligence, okay, as a starting point of it, so that we can understand the behind or the background of this technology. And then we want to go backwards, maybe in the early of 50s, where we want to relate that intelligence created artificially with the biological neural network that we have in our head, which is our brain. Okay? And after that, we want to know what are the possible problems that commonly can be solved by ANN, especially in the civil engineering domains. And we want to know some of the ANN challenges that will be faced by us as a researchers and also as engineers. And after that, I'll be more focused on the application itself, on the civil engineering research works and also civil engineering activities. And we want to know what will be the future direction of this ANN, so that we can cope with the technology and we know what is our contribution on that along the activities of the future directions. Okay, so before we start, this technology, AI or machine learning, in actual is not in my list of my research work. But when I did my research work at the University Kebangsaan Malaysia, I'm using this kind of equipment. So that you can see that this is equipment that you call as GPR, the ground penetrating radar. So basically, this equipment will try to understand what will be the surface that will be scanned underneath of this antenna. You can see that there is a red box here. Is an antenna. So this antenna will emit certain electromagnetic waves, propagate to the medium. So in this medium, we call it as the bitumen medium. And that things inside that medium can be traced and can be identified by this equipment. So this is the starting point. Suddenly in my life, I really care about artificial intelligence. And what of the problem of this equipment? The problem of this equipment will be that it's just only giving the measurement in terms of this only. Okay, so we have two kind of measurements, which is in the signal form that you can see on the first picture here that we call as A scan, and this signal form will showing the magnitude of that signals versus with the depth of the material that will be investigated. And another kind of measurement or the reading can be come out from that equipment that we call as a radargram, or some people call as a B-scan. Okay, the problem of these two measurements is that you have to interpret the reading by experience. This is the total problem of this equipment, so that we have to live with the equipment maybe for several years, understand the signal variation towards to the targets inside the medium, and relate what will be the possible things inside that bitumens, inside that concrete, inside the source. So this will be a problem to people like me on that time, because I have to understand what will be the features, what will be the signal if let's say that EM wave hit rebar. So when hit rebar, maybe the signal wave must be longer, or maybe from the B scan, you may see a very sharp image. So for a novice people like me on that time, I cannot differentiate. So that's why I have to learn another technology on my own that is not inside the objective of that research, by using artificial intelligence. Okay? Why artificial intelligence? Remember, artificial intelligence will be a technology that you can train a system by learning the data. So we have a lot of data here. So let's say I do 100 measurement, let's say on the same object, and I get 100 diagram. And that diagram, we can ask the system to learn and identify what will be the possible targets. So this is the turning point where suddenly in my life, even though I don't want to know about this, but I have to do this because we want to understand the thing inside this surface automatically without any experience. Because remember, if you put the same diagram this to, let's say, 5 experts of GPR, you have 5 different conclusions because the background of knowledge understanding that signals in the E scan and also the radiogram in the B scan will be varied depending on the years of experience, the emotions, and other factors that can affecting the interpretations. So that's why suddenly I started to use and like to use this artificial intelligence that is started by the artificial neural network. Okay? So hopefully you understand why suddenly I choose this topic and learn this topic and live with the topic until now. Okay. So some of my research that I've done on that time is to understand what will be the amount of the moisture content in the concrete cover. Okay? So let's say this is a concrete and this is a large enlargement of that cover. Remember, this is a cover. So maybe the cover will be 30 mm, 25 mm, depending on the design. And we will put certain amount of moisture content inside this. And we will put the GPR antenna on the top of this. And this antenna will radiate certain EM wave, electromagnetic wave, through the medium, and the medium will be reflecting some of the energy back to the receiver antenna and get the reflections of that signals. And remember, as I said again, big signal variation is very complex, and you need a way to understand the relationship between the signals reflections and also the amount of the moisture inside the concrete cover. Okay. Why I'm studying this, the moisture content inside the cover? Because I want to know the state of health, tahap kesihatan, the state of health of concrete cover. Okay? Remember, if you don't care about your concrete cover health, then in the long run, you will face deterioration of your concrete quality, especially to the reinforcement, the rebar that will be corroded once the amount of the moisture content is exceeding certain threshold values. So that's why I'm doing this research to quantify the severity of the health of the concrete cover, due to the amount of the water. And also on that time, I introduced amount of chloride. And remember, a concrete that is embedded inside seawater or maybe to the environment containing chloride can also allow chloride to be penetrated inside the concrete cover. So the same experiment also was done on that time, about 2015, 2016. And I also get a very complicated signals. And on that time, there is no one in the world doing the research that relates how the amount of the water and chloride simultaneously affecting the GPR signal. Okay, so on that time, I do some of the sample like this. And this is the samples. There are it's about, I think it's about 300 mm times 300 mm times 200 mm thickness, because I want to simulate the bridge deck, the bridge deck slab. And this slab will be covered by tin foil aluminum because we want to conserve the amount of the water that has been introduced and the amount of the chloride introduced inside of this sample, because we will put the sample inside the oven, and the water content and the chloride content will be homogeneously, hopefully, distributed throughout the thickness. So that's why you have to cover with the tin foils. And we get some results, and this result I have to tutup lah, because this is a secret, and we have measure the amount of the chlorides and the moisture content with the data of the GPR. And once I plot the relationship with by 3D, because on that time there is no empirical relationship developed by researchers on that time, and I'm using a normal regression only, okay, and it is being published by this journal, Construction of Building Material, I think in 2016, volume 106. the ground penetrating radar waves attenuation models for estimation of moisture and chloride content in the concrete slab. On that time, I do it with my supervisor, okay? And we get this. But on that time, I don't do any artificial intelligence. I just use only polynomial or maybe nonlinear regression, try to release the free chloride content that you can see on the screen, and also the moisture content on this axis to determine how much is the reflected wave. So if let's say I do some experiment on the concrete cover, I get certain amount of reflection of the GPR wave. So I can use this curve to estimate the amount of chloride content as well as the moisture content by using this complex surface. Okay? So we have two models here. One is due to the direct wave, another one is due to the reflective wave. So whoever in the GPR, maybe you will know the difference between these two. And this is not yet used by a lot of researchers on that time. So that's why we successfully published one paper on that time. And after that, I tried to use B-scan. I tried to extend my research somewhere in the 2019, and we published this paper where we tried to detect the damage of rebar that has been artificially corroded. We are not using the actual corrosion mechanism because that will be too long. We are using a current press system to simulate a corrosion on the rebar, and we get this is the sample. The sample, the slab itself, is a 500 mm by 800 by 200 thickness to simulate the bridge deck, and this is the system that we used to corrode initially the rebar, and we embed back that corroded rebar inside the slab, and we scan by GPR, and we get these complex images. This is, we call it as a B-scan. The bottom one is the E-scan. So on that time, I found that the need to use artificial intelligence, which is AI or ANN, to recognize what are the features inside the image that can be related to the damage severity of the rebar. Because as a normal person, you cannot quantify how much is the rebar corrosion, just look at the images. And that will be the job of artificial intelligence. So that's why I jumped to this field, and we have published a lot of innovation by using this technology only. So that will be the motive why I'm using this. And I think the lecturers in the UNIMAP and also the students can also take this motivation maybe to develop your research, maybe in your master degree or in your PhD, or maybe in your final year project, because this is a very interesting project, because you want to interpret automatically what are the damage severity based on images. We don't do any measurement, but we just only pass our image to a system, then the system estimate the severity of that damage. And the system also as well can classify the damage type, whether it is to be crack problem, is it due to by corrosion of rebar, or maybe is it due to void problem, and so on. Okay, so these are some of other works that has been published by using GPR system. And in this paper, I have already applied the artificial intelligence in order to perform the automatic assessment due to fire affected axis slab, because it's a very, very good way to interpret it without any human guidance at all. So I think this is 2019, I think, this paper in this journal. And this is the structure that we have studied. Is a hospital at Kuala Lumpur. I didn't remember the MRI building. One of the block has been under fire, and we are required to investigate the damage severity. And this is the place where we focus, and we get a lot of these images. So imagine for a novice people who doesn't know to interpret these images is a problem. because it's just like if let's say you bring your wife, your pregnant wife, to a doctor. I think whoever have brought your wife, and the doctor will use some kind of equipment that put on the stomach of your wife, and see the images. So for a trained doctor, the doctor can understand the thickness of your baby, where is the baby head, and so on. So the same thing here. So we are acting as a doctor, but a doctor of a building. We try to understand the location of that problem and how will be the problem severity. So as I said again, for a novice people who are looking on these images for the first time, you maybe just only dots and spots, but you don't know how to interpret it. But for a trained eye like me, by manual approach, I can identify the concrete deterioration here existed, and some cracks also introduced at certain depth of the concrete due to the fire affected system. So if let's say these images is passed to another person, this is a problem. So that's why we need artificial intelligence to perform the assessment automatically without any human expertise at all. Okay. So this is some of the innovation that we have entered by my students. You may see that I started to aggressively using this technology to perform damage concrete classification, identification, and we get gold for this. Another innovation in the exhibition, we also I think we get silver here for these people, because the student does not really well to present the innovation. In fact, the innovation is very good, but the marks will go low due to the presentation. But I think this is a good innovation during the exhibition. We use KNN, nearest neighbor. So this is the algorithm that we use to detect the features of the classification. And also another exhibition we entered by using support vector machines. And another one is the more, I think, the more popular one, which is by using, not this one, this is NIF Bayesian classifier. We also doing the damage classification identifications. This is the most, I think, popular by using the pre-trained deep learning. I think most of you, I think, come across with this word, deep learning, in all of your YouTube videos. So this is the, we got goal here for this exhibition, where we train the images that we get from concrete to detect the damage kinds inside the concrete. Okay. And after that also, I'm not only focused on the damages, but also I'm also use artificial neural network, which is the subset of the machine learning and also subset of your artificial intelligence to perform concrete mix design. So usually I think most of you will do the concrete mix design in your class by using the DOE method, and you have to use a lot of charts, a lot of tables to perform how much will be the amount of the concrete, the amount of the water, aggregates, fine aggregates, and so on. But using this system, we can use, we can specify what will be our grade, what will be our environment, and then the system will choose you the best ingredient that you can put to your mix in order to achieve that minimum FCK or FCU. But we are using data sets on the experiment. We are using data sets in order to create a model that can predict automatically what are the ingredients. So I'm not using my AI knowledge in the damage research, but also I'm doing for the material research as well, because the domain of application is very, very vast, is very big. We also try to do a research, and we have published this paper on classifying the fruit ripening stage. In Malay, we call it as tahap kemasakan buah. That buah is a species called as ficus carica is a I didn't remember, but this is not a Malaysian food. Right? This is cold country food. What we are trying to classify the ripening stage. So we are using the deep learning with my team to estimate the ripening stage. So you may see that this technology is not only used in civil engineering. We can apply to anything. And I have also acknowledged that some of the people nowadays using artificial neural network or AI to estimate what will be the stock exchange, the stock exchange variation. So they can estimate the price stock exchange in the current state, and you can do some kind of decision to on that domain. Okay. So what are the current needs? What are the current needs? Okay. So my current needs is we need to interpret the image automatically. So whatever image that you wanted. So maybe in my case, I want to interpret the image when I scan the concrete by my GPR. Maybe in your interest, you want to know what is the object inside the image. Maybe you want to differentiate the image due to rebar, due to cement, due to water. So maybe I do not know. So we don't need any human to interpret, but we need a system, and that system will be run by artificial intelligence. We need to identify that problem. Maybe in my case, I want to identify the damage. We want to locate that location of the damage, in my case, and we want to classify the damage. We have a lot of damage. We have cracking image, honeycombing, voids, corrosion, spalling, and so on. And the last part, which is the most challenging part, is to quantify or to measure that problem instantly. In my case, to measure the damage state. How many percent? Is it 30% of corrosion? How many length is the crack? Is it the width is 2 mm? What if there is a void? How large is the diameter on average? Is it 1 millimeter? So that will be the most challenging part, but it's not impossible done by artificial neural network or artificial intelligence. Okay. So now I think I have gone through a lot on the artificial intelligence, but we can say that AI has a lot of application nowadays, and it's a very popular to the human need, not only in the practicing field, in the civil engineering, but as well as in the research civil engineering works also. And a lot of companies worldwide now investing their money because they can see a good fortune of this technology in the 1 decade. So because that investment can solve various fields and bring money to them, because that will bring money to them. And if you apply a lot of money in the research, that innovation will also give you famous, and you will be get also money to your university. In a lot of engineering disciplines. And in every engineering discipline, why we need AI? Because we need decisions. And remember, usually decision is done by expert peoples. And we are lacking of expert people in the world. So how to copy their expert mind so that this mind can be contribute to the society that need it in a system. So that's why we need AI, because AI can copy their mind, and and that mind can decide for various a lot of application, and especially we want to achieve certain KPI, certain objective. Okay, so what are the fortune of this AI in research work? So maybe some of you tertanya-tanya in question. So we can see from the trend of the publications. For I think about for 10 years or 5 years, and we just only selected from 105 numbers from Scopus databases, only journals, no conference, only in civil engineering domains, and that was done by this researcher from, I think, from University Technology Petronas. This is a lecturer from University Technology Petronas in the people called as Applied System Innovation. So you may see that the trend is very, very good. You can see a very exponential work done, published by this field only. And it is started by 1995. It's very, very small, but the numbers keep going up until 28 in the year of 2020. I think in the year of the COVID-19, and maybe some of the work during the COVID-19 2 years, because we had COVID-19 for 2 years, and some of the work, the numbers is going down, because much of the work cannot be done, especially to get the data. So that's why you have a downward trend. But I don't think this trend will be downwards. It will be keep positive until 2030. So it's a very good prospect doing research in the academic world. You can see the publication. Okay, and the publication has been done by typing this these keywords. So we type a lot of this word and we get this publication. And in terms of journals that has been contributed, you can see that a lot of the journals focus more on the automation, because remember, AI is for decision making. We want to have automated decision. So that's why a lot of researchers like to publish in this journal, automation in construction, about 57% from the 105 papers, and followed by the advances of civil engineering, and the very small part, which is 1%. I think this is a journal which is not so famous, but people still publish, Arabian Journal for Science and Engineering. So you can see that this is the journals as academician that you can publish for the work involving artificial intelligence. So you can select automation in construction. This is quite famous journal and a very prestigious journal. I think it's a Q1 journal. Okay, the geospatial distribution. You may see that as a Malaysian people here, we have one publications that has been detected, and this one publication is only due to the Scopus, not the conference. And we are starting, we are the country that's starting to involve in the AI. And the more country that has been involved largely is from the USA. So after is China. So USA and China is a place if you want to do sabbatical leave for AI, so you can go there, because there are a lot of advances involving AI in that country. So we are just about to start this, and I think this trend will be more and more in the coming years. So I think it's not too late for us to involve with me. Maybe you are more expert than me to enrich these divisions. Okay, remember that the substance, the main substance of AI is data. That is the most important part. The data, a large amount of data will be the sumber, the source of the model. However, from dapatan from a consultant company from UK, especially in the construction, not in the research work, 96% of that data that is being accumulated in the office is not used in that industry. It's not used in the civil engineering industry. So imagine that if that data is passed to us as academician, I think we can do a lot of things in research involving AI to help the industry. So I think it's an opportunity for the lecturers as well as the student to ask the industry that is usable to the AI, so that you can make use this data, and we will build our AI model to help the construction teams outside. So I think this is an opportunity to us to do the thing. And in UiTM Penang itself, we have already approached and also get the job from the Jabatan Kedua. jambatan kedua that linking the Batu Kawan to the Batu Maung. And we have already given the job to classify the damage based on the accelerometer data that they have since I think 5 years ago, but not yet analyzed. So we are using that data to classify that damage, and we can consult them what are the severity and the repairing work. So I think you can do also the same thing with the nearby industry to get what are the data, because most of the data is unused. They just put inside the office desk and they don't do nothing. Even in fact, if you combine with AI, you can solve a lot of problems. Because as I said, data is the capitalizing aspect that will color the image of the construction industry. So we try to turn the knowledge into actions. And this is some of the companies in the worldwide has been used AI. You can type Google, Cupid Build Smart, that has invented this system. They can collect the data by using their cameras on the site progress, where you can see whether this column has been fabricated or not, and they can map the state of the construction stage. So you don't need any, you maybe need some people to supervise, but the number of the supervision will be minimal. So you reduce the cost of the construction by using this AI system. You can view the site remotely, and we can get the data. So, as I said before, data is the essential part of the AI system, where we can perform decisions on what to be done. If let's say today this column should be fabricated, but by using that camera, it has been detected that this column is not yet fabricated, and the system artificially will try to find you and report. And as an engineer, then you can act on that problem remotely, so you don't need to be at that place at all times. So this is one of the company. So there are also another company, Quan. Quan. This is a very good because it will. It has been invented a system where it will monitor the security, the safety on the site remotely. So they will wear a kind of helmets. I don't show the picture. That is have sensors. So that sensors can detect the distance between them to the nearby structures. Are they hanging? Are they falling? And so on. So the system will send amount of data to the server. So meaning that the site must be equipped with the internet IoT system, and that server will send the signal to the builders managers, and they will act it promptly if any accident happens. So you don't have to put a lot of people there to perform safety measures, but you can use AI system to monitor the safety of the site by automation, and you can respond to the system. This is another one, versatile, using a crane. So this crane system can monitor the work performance of that people that are using the crane, because remember, crane is a very expensive equipment, so we need a people that using the system carefully. So we need a system to monitor intelligently. And this is one of another company, Dusty Robotics, and you can see by a video after this what this company contribute to the civil engineering activity at site by using artificial intelligence. So please. So this system is using robots, and that robots can draw on the slab, where is the location of the wall? And you may see that the dimension is correctly printed on the slab. This is done by artificial intelligence. And there is one person there controlling the system. So this system will give a good efficient for the laborers so that they can put their wall on the right spot. So imagine how much the cost will be reduced by using robots. And this drawing is drawn by BIM technologies. I think most of you knows about BIM technologies. So that robot do his job or her job based on the drawing done by BIM, building information modeling. I think most of you knows about this. So that's why I think it's a good for all of you as a student to study about BIM, because BIM is one of the technology that link to the AI. So it's a good starting for the student to learn BIM nowadays before you graduate. So that is my advice to you. So the preparation for your student before you entering the job market. Okay, nowadays we have confusion between AI and machine learning. So this word has been used interchangeably without noticing the difference with them. So that's why I give you some definition so that we can understand that definition generally. So AI, what is AI? AI is referring to a technology. It's only a technology that try to makes the computer learn from data. As I said, data is very important for your artificial intelligence system. And after learn the from data, it will perform decision. And that decision will be done without any programming. So you don't have to perform explicit programming. You have to done only implicit programming. So meaning that your programming line will be very less, very minimum. So this is the meaning of AI. It's a technology that allows the computer to learn from the data so that the computer system can perform decision that may be better than human. And ANN is what? ANN is a subset of AI. Is a specific type of machine learning model. And this model will be motivated by human brain. So we try to mimic human brain that has been devised by our God. So that brain system will be modeled by ANN. So that is ANN. It's not the same like AI. AI is the technology, whereas ANN is the model. It's a model that try to mimic human brain mechanism. And machine learning, what is machine learning? Is a discipline of knowledge. It's a discipline of knowledge that create computer algorithm. So this knowledge will create a computer algorithm so that it can build intelligent machine or device that can perform a lot of things tasks by humans, and that decision also can be done better. So this is the differences between ANN, AI, and machine learning, so that you can use it definitely in your communication. So in actual, I want to talk more on ANN today. Is the model that try to mimic human brain, and we use this model so that we can get a system that can think intelligently as human brain. Okay, what are the basic type of problem can be solved by ANN? Remember, ANN is a model. So basically, we have 4 kinds of problem that we can solve by ANN. The current of my work is focusing on pattern classification and also forecasting. So this is my 2 domain of work. we can classify the pattern. So in my job, I try to classify the damage types, whether the damage type to be class 1, or let's say class 1 is a corrosion problem. Maybe the problem is class 2, maybe due to honeycombing, or maybe the problem can be class 3 due to, let's say, cracking. So we try to train the images. In my case, my data is images and videos, so that the system can pick up what are the important features from that data and use the various algorithm that we have. We can have KNN, we can have SVM, we can have Bayesian neighbor wave, we can have deep learning, so that it can classify to whatever class that it wanted. And remember, in my case, I just use only supervised learning. We have 3 types of learning. We have supervised learning, which is in my case, meaning that I know the damage before the model has been done. We have unsupervised learning, where we don't know the types of the problem. We ask the system to arrange the classification. And the third learning is the reinforced learning. We try to make the system better by reinforce the experience, so that the system can intelligently select the optimal decision. So in my case, I still in the first phase, which is the supervised learning. So we can also have the problem of clustering, where we try to cluster. So this clustering is more on the unsupervised learning. We try to cluster. The third one is for functional approximation. So I think one of the work that I have shown you is about to perform the concrete mix design. So that concrete mix design publication, I'm using this kind of solution, which is by approximate the function. So remember, in your concrete mix design, you have a lot of tables, you have a lot of graph. So I try to convert that graph and tables into ANN and approximate the function, and that's why I can perform that estimation of the concrete mix design. And the last one, as I said, forecasting. One of the examples have been given to you is to forecast the stocks exchange. So I think the nowadays is the most serious one is the nilai ringgit Malaysia, which is jadi jatuh because of the increase of the US. So maybe if you like to model that pattern, the currency range of exchange between Malaysia and US, you can try to do that and forecast what will be the future of our ringgit Malaysia, whether to be turun ke will be naik. So we can do that. So this is the basic types that you can model or you can solve by this ANN. So remember, ANN is what? Is only a model for solving problem by mimicking human brain mechanism. Okay. And why we use ANN, artificial neural network? Because of these 2 factors. The first factor is due to the learning ability. So our NN have the flexibility to learn anything. I said again, to learn anything. There is no impossibility. All are possible by using ANN because it has a lot of learning ability. And by using this learning ability, you can construct a model that can describe the cause and effect relationship. So as I did in my concrete mix design, I make a model that can show the cause and effect. So the cause will be the factors controlling the cement concrete grade, which is the water content, cement content, fine aggregate, coarse aggregate, maybe you have super plasticizer and so on. That is the cause. And the effect is the concrete grade. And in reality, because the relationship between that cause and effect is very complicated, because you have to use a lot of graph, that's why I'm using ANN. Because as I said again, it has a very flexible learning ability. Tak kisahlah macam mana kompleks pun, it can learn. And that learning, when I done with my MATLAB, I need about 4 hours to train the model so that the model can adapt to the changes of the parameter and you get the model. So it's not easy, but it's very possible. You have to invest your time and you have to have a very good computer system because you want to perform a numerical algorithm calculation. And the special feature, as I said before, has a unique ability to extract meaning from imprecise or complex data. Ini yang best ni. From any complex data, doesn't matter how complex it is, it has ability to extract. And that extraction will be given after this. I will show you how the system extract the meaning of that information. The second point why you use NN, because the system is very robust and fault tolerance. So if let's say your data, you collect certain amount of data from an experiment, whether at site or whether at your lab, some of your data usually contain errors because of the equipments, because of the material handling, human factors. And this kind of problem, this fault problem can be tolerable, can be tolerant as a noisy, and we can remove that noise data prior the analysis, and we make our data more better because we have screened it. We have to screen it before we put inside the system. In fact, even though you are not screening the data, you can also use that data as well, and the system can tolerate with that problem. Because why? Because we have a lot of nodes. So I will show you the meaning of nodes after this, and also the connections that try to distribute that amount of noise ataupun errors so that your system much more robust. So that's why I like to use NN in my research. Especially, there's one point here. If let's say you have a lot of data, I think that this is the next slide. You have a lot of data, but there is no empirical equations, meaning that there are no person like to get relationships, but you have a lot of data. So NN is the possible solution on your research work because NN can adapt your data and get the relationships. So as I said before, when data is abundant and there is no unclear theory, then you can use ENN. Okay, so if let's say you have a lot of equations, so there is no need to use NN because you have a lot of other equations can explain that problem. So maybe you can use NN on that time as a comparison only. But if let's say your research is very new, but you have a lot of data, you collect a lot of data, then this is a possible ways how to manipulate NN to be adapted in your data. Okay. So now we want to go deeply how the ENN is used to learn the data, and after learn, it can perform decision. Okay, I give you an analogy from the baby until to the adults. So as a baby, if I'm focusing to the baby brain, okay, inside the baby brain, you have a lot of neurons. So I think hopefully you know the meaning of neurons. Neuron is the biological cell inside your brain that perform thinking, that store information and so on. However, this is due to God's will. The neurons are not connected well. The first neuron to the second neuron may be connected, but maybe neuron number 2 to neuron number 3 is not yet connected. So as the number of the neuron is being connected by age, then your brain will have much more better thinking capabilities and can perform better decisions. Why you can perform better decision? Because you learn from data. So the baby can learn from data from your father, from her mother, from the surrounding that giving you the input, and the brain learn that experience, and the neuron will be connected and connected and connected until to the mature stage. If let's say you can see this girl, almost of the neuron inside the brain has been connected. So when you have a lot of neuron has been connected, then your thinking capability and your decision much more matured and much more meaningful. So this is how we will develop our system artificially. So that's why we call it as artificial neural network. Neuron coming from the word of neuron, from the human brain. Artificial because the system is made by artificial in the computer system. Network, the system is only running because of the connection between of the neuron. So that's why we call that system as A and N. So hopefully now you understand why word A and N is coming in a lot of papers and also in the reports. It's coming from that scenario. Okay, this is one of the microscopic, just only schematic drawings in the human brains. So you can see here, this is the large ball here, the large circle here. This is the nucleus, okay, which is the focus of the neuron that will collect a lot of information from outside. So how it collect the information from outside? From the dendrites. You can see a lot of networks here that is connecting to the nucleus. So this dendrite will allow inputs from the surrounding. So the input may be from heat. If let's say you touch your hand to a heat source, logically within millisecond, you will avoid that heat source automatically. Why? Because your hand will transfer that heat signal to the dendrites. That dendrite will send the signal to the nucleus, and that signal will send to the axon. It's a long cable here, like a cable light, to the synapse, and this synapse will connect to another neuron. Okay, and when the signal of the heat is exceeding certain amount of threshold value, then you will have a connection from this nucleus to another nucleus. So meaning that on that time, you have a decision. So your decision will be that your hand will be avoiding that heat source. So that is the system will be copied in the computer artificially. So again, I want to wrap up. In the neuron, you need the inputs. Okay, you need the inputs. You need a network connections by the axon, and you need to have a transferring mechanism from one neuron to another neuron by this system that you call as synapses. And this synapses will only activated when it is exceeding certain signal threshold. If let's say it's less than certain signal threshold, then that connection does not hidup. It will be die. So once the system is exceeding certain signal, and that system will be turned on, and the decision will be created. So that's why if you getting older and older by your you have to do something on your brain. You have to read. You have to do something that trigger your mind so that your neurons still connected. So that on that time you still have the thinking capability and your brain still healthy. So don't just duduk saja bila dah tak ada buat apa. Do something so that your brain is being connected from one neuron to activate the jaringan, the connection. So this is for your own knowledge. Okay. So once the signal is being exceeded certain threshold, the process of learning occurs. This is that we want from the system, to learn from the system. How the learning system done? When the signal from the synapse more than certain amount of value. So in biological, how the system is connected from one neuron to another neuron, this synapse will excrete certain kind of hormone. So it's a kind of hormone that will be released, and that hormone will be transferred to another neuron and connection occurred. So that is from biological point of view. But from computer simulation, we'll use certain mathematical function that will be activates but when the amount of signal exceeds certain signal value, so that the learning can be occurred. Okay, so that is ANN. ANN is a model that learn by mimicking human brain. Okay, so now we are talking about the artificial neural network that is being simulated by computer. We have a lot of ANN classification in actual, but I just give you only three. The most three important neural network that has been nowadays. In actual, we have a lot. The first and the basic one is the multi-layer perceptron neural network, which is basically for simple system. For simple system, let's say in my case, I'm using simple system for predicting the concrete mix design, where we have amount of inputs here. So we have to find what are the inputs of the system. So maybe in concrete mix design, the input will be the amount of cement, the amount of water, the amount of concrete aggregates, fine aggregates, and so on. And we have one output here, which is maybe the concrete grade, the targeted concrete strength at 28 days. And in between of your input layer and output layer, we have an internal layer here that we call as hidden layer. This hidden layer that we call as the thinking layer. This is the thinking layer that will do a lot of magic to us, that try to find the connections. You can see here a lot of arrows here. These arrows is the connections from one neuron in the input to another neuron to the hidden layer. So if that amount of that signal from this input is exceeding certain amount, then this neuron can be activated. If let's say, the signal is not so strong enough to this neuron, so maybe this neuron will be die, and so on. So by finding the right pattern of die and on of the neuron, then you can have a lot of active connections, and you can get a model before arriving the outputs. Okay, so basically, when the number of the hidden layer here, so can you see that this is hidden layer? The number of hidden layer is only one. We call it this one as the shallow ANN, shallow ANN. Whereas if you compare with another system here, when the number of the hidden layer is now more than one, this is the first hidden layer, this is the second layer, maybe you have the third hidden layer, maybe. So when the hidden layer is more than one, we call this one as the deep neural network, DNN. So remember, the difference between ANN and DNN is when the amount of the hidden layer is exceeding one. So that's why you can see a lot of papers stating about the deep neural network, when the hidden layer is more than one. And usually when you need more than hidden layer, more than one, when the problem is complicated, especially when you're dealing with the images, because images, remember, images containing spatial information in the two directions. If you open a picture, you can see that your picture have two dimensions. So that's why you have a lot of more thinking layer to perform the decisions. So for a problem like concrete mid design, I think I need just one layer, and by 4 hours, I can get the model. Okay. And if let's say you want to use a more complicated neural network called as RNN, you can do that. This is usually done for time series data. If let's say you are dealing with the hydrological data, rainfall data, you want to estimate the severity of landslide, you can use this recurrent neural network, because this is more done for the time series. You can use, you have two variants. In actual, there are a lot, LSTM and GRU. And here, it is good for time series. I don't say that you cannot use time series for the multi-layer, but it is best to use this one because you have a lot of algorithm that allow you to facilitate the time series computation, much more easier. And the more famous one is the CNN, convolutional neural network, vastly used in the electrical engineering, and nowadays also spread to another fields where you use images, videos, audios, and so on to learn from that data and to decide something on that one. And in this convolutional neural network, you have a pre-trained deep learning model. You have AlexNet, VGG, GoogleNet, a lot of pre-trained. So what is the meaning of pre-trained? Pre-trained deep learning is the brain that has been trained by people outside, and you just only borrow their brain. So this system, if you are using pre-train, much more optimum because you don't need to train the brain anymore. You just borrow and you just put inside this convolutional neural network and learn from your data and decide something. And this is also my field where I'm using CNN to classify the damage states in my previous exhibitions, where I learn the damage from the images and I find what kind of the damage inside that concrete. But I'm not using any pre-trained learning because that is too easy. I'm creating my own brain, by designing the layers of that thinking layer. So there are a lot of another cabang you can find on your own. This field is still growing and growing, and I think it's not too late for you to join because it is still in the early stage, especially in Malaysia. Okay, so this is how the artificial neural network learn. Okay, as I said before, in order to learn, you must have at least 3 basic layers. The first layer at the bottom here is the input layers. Okay, input layers. As I showed in the previous diagram, this is the input layers. The same thing. Only the position is at the top here, but in this slide, the position is at the bottom. Doesn't matter. The orientation doesn't matter. Only the first stage of the nodes is the input layer nodes, where you supply the cause of that problem. So in my example, let's say in the concrete design, the cause of the problem or the input of the problem will be the water content, cement content, and so on. For let's say images, I have to supply what? Maybe I have to supply the amount of the pixels, the brightness of the pixels, okay, the GLCM matrices, and so on, depending on your problem. And we have one output layers, the output that you wanted from the system. So in this slide, there are 2 outputs. In fact, usually I just put one output because one output also you need a lot of time to invest it. I just want to get one concrete strength. I need 4 hours. Imagine if you put 2 nodes, so maybe 8 hours or 7 hours, depending. And it depends on your system because my computer is i7. So I still need to have 4 hours. So in order to make your system does not hang, it's better to only to put one output. So if let's say you have 2 outputs, maybe you have to run 2 computers. You have to run for one output, you have another computer outputs to run another output, so that you don't share the same resources to do 2 outputs. And in the middle part is the thinking layer that we call as the hidden nodes, ataupun hidden layer. And when the hidden layer, as I said before, is more than one, that system we call as DNN, deep neural network. So this system is the ANN only, is a shallow NN, it's not deep. And by using this system, we try to find what is the connections within each of the inputs to the hidden nodes. You can see that we establish a lot of connections here by these arrows on each of the inputs, and each of the connection will be assigned a random value of weights. Okay, what is weights? Is a value that can be negative value, it can be a positive value, it can be an integer, it can be a decimal number, it can be a fraction, any values that will be distributed randomly, and that numbers will be multiplied the input here. Okay? So when you multiply the input value here, let's say this input value is 3, let's say, and this connection to this connection, you have a weights. Let's say the value of weight is 0.1. So when you multiply 3 with 0.1, you get 0.3. Okay? And to activate these nodes, you need a transfer function. Okay? So remember, as I said before, when in the biological system, if I refer back, when the signals here is exceeding certain amount, then you can pass that signal from one neuron to another neuron. So the same thing here, when this signal value, let's say 3 times 0.1, you get 0.3, is more than certain value that is allowed by the system, and that connection will be passed to the next neuron. If let's say that signal summation value is not exceeding certain amount, this connection will be abolished, will be terminated, and will find another connection. And this thing will be done automatically by the computer algorithm. So that's why we need about 4 hours to do that. Because in my system, even though I'm using a lot, one only hidden layers, but I try to use a lot of inputs in actual. Okay, so this is the basic structure, or some people call as architecture of artificial neural network, in order to mimic the human brain activities, so that we can get a model that can predict or classify for our objective. Again, we have talked about this one. The behavior of artificial neural network is particularly depends on the structure of each nodes, okay, the structure of the network, and the weights on each of the connection. So we can in actual, before we do any job on NN, we have to propose the system of the NN. So maybe when you do one simulation, you can propose 3 kind of architecture, and we run simultaneously. And from that simulation, the system will select which one is the best. Because, as I said, the system depends on these 3 factors. So we can vary the structure, we can vary the activation function, we can ask also for different values of weights. So we can have a lot of infinite numbers of NN system before we get the optimal one. And this is the same thing that we have discussed. We have to initialize weight, as I said, on the connections on the network, and we have to perform the multiplications between the weights and the inputs. X is the input, and we get the summation. And when the summation of this is more than certain values, then we can activate the signal to the next neuron. If let's say the signal here is less than certain number of value, then we have to stop that connections. And once the connection is transferred, we can compare the outputs of the actual with the predicted. And if there is difference between the actual and the predicted, we can count what are the errors, and we will distribute these errors, delta W, to the system back. We repeat until we get acceptable level of error. Meaning that the error will fall to a certain amount of value that you prescribe. So maybe you describe the error, let's say, to be 1 times 10 to the power of negative 100. So the system will try to iterate maybe until 4 hours, until the level of the error is less than the prescribed value. So this is how the system learn, by updating the weights, delta W, so that our level of error, meaning that the differences between your output and the predicted by your system will be minimum or very, very small. Okay, so I don't want to talk about this one. This is more on the mathematical part. Maybe it's not it's not so interesting to talk about mathematics today. It's better to talk something on the simulations, or maybe the videos. So just for 30 seconds, this is the function that we call as the activation function. One of the activation function, we have a lot. We have sigmoid function, we can have ReLU function, we can have tangent function, and so on. And this function is for what? Is to check whether your connection system signal is exceeding the threshold value of signal or not. So this is mimicking the synapse. The synapse, as I said before, where is the synapse? The synapse. We try to mimic this scenario by using activation function. So by using various value of activation function, we can have a lot of system of ANN. Okay? And remember that when you want to prepare for your ANN system, remember any input that you want to fed must be very, very significant. It must be clean. There is no error if possible. Let's say the data is complete, so that when you put a good input, then you have a good output. Remember this phrase, garbage in, you get also garbage out. So you fed wrong data, you don't have, I don't think you can expect a good model. I think in anything, in any model, linear regression ke, polymer regression ke, response spectrum ke, you need a very good data, because the quality of result it directly relates to the quality of data. And usually, before you fed your data to the system, some of the data will be partitioned and treated as a training data. Let's say you have 100 data, and let's say I take 80% of that data as a training system. So meaning that 80 data from that 100 will be taken out and fed to the system. So you have another 20 data left that will be used for the testing. Meaning that after you run that ANN by using that 80 data, you run, let's say after 4 hours, you get one model. And to check whether your data, your model is correct or not, or accurate or not, you will use that 20 data that is not seen before by that training data to check whether it meets or not the actual prediction. So in this slide, it is shown that 50 to 70%, but usually I will start with 80 to 90. 80 to 90. So before you prepare your data for feeding inside the ANN as an input layer, ensure that your data has been consolidated and clean from any errors. Meaning that you check there is no missing data. Let's say the data only contains numeric number. Okay. And then you have to perform selection and pre-processing. So you can do this by using your statistical knowledge. You can process your data, and maybe some of data need transformation. As example, if let's say your input is try to relate the state of student absentees inside your class to the CGPA, so your input data maybe will be hadir class or absent class. So before using 2NN, that hadir, which is in the word, you have to encode it to maybe number 1. Absent, you have to encode it to be 0. So that is the meaning of encode. You try to convert from word to numeric so the ANN can easily learn the data. So this is say as data preparation. You must prepare the data before do any ANN. And as in the statistic, you must recognize the type of data lah, macam biasa. You have nominal data, ordinal, interval, continuous, because this data will greatly affecting your data preparations. And usually, in my case, to make my model to be much more faster to iterate, usually my data I will put in a range. I will convert my data to certain range, meaning that I do transformation, data transformation. Because your data will be maybe -3,200. You have data to be 1. You have data to be 1 times 10 to the power 9. So that number of arrays, I will try to transform to be certain range so that my model can faster converge. If not, maybe I have to take longer time. So this is my practice. I'm using the data that has been in a certain range. Okay. In real life, what I'm talking just now is more on the research work. We are not yet talking about the real application in the civil engineering work, meaning that as engineers outside. So to make sure that your NN much more commercial based, can bring money, can be commercialized, usually you will top up by IoT device. You will top up. Your algorithm, you must plus with this cloud computing, computer visions, and sensors. So in my case, I have already done it because I tried to mix my GPR and also my camera with ANN. So to make sure that that innovation to be much more better commercialized. So what is the cloud computing? I think most of you know cloud computing. Remember, your data has been taken continuously for 24 hours for 1 year. Imagine, I don't think you can store that image or store that data in the pen drive or your computer on your hard drive. So you need a system that can store the data instantly, real time, and also you don't have to carry the data. So by using cloud computing, that data can be stored and you can access it plus with your AI algorithm so that it can learn. Because you want to go commercial, remember, commercial people don't want this problem to become out. So you have to solve it. Another thing is to use the computer vision. Computer vision is to use camera and computer as a data collection. You use camera, you can see here a camera here on the top of this peel. Try to monitor the peel production. So this camera that attached to a computer, we call it as computer vision. So we gather the data through a camera. We are not taking manually lah. You're not using your pencil and paper, but you use more better system to accumulate your data. So your data here will be the videos and also pictures. And sensors, let's say if you want to monitor the acceleration of your bridge, so maybe you need accelerometer lah, attached to the bridge component, and should be that sensors can transfer the signal to the apa benda ni orang panggil server, server. Or maybe you have stored a device that can store that signals on the bridge. And these sensors will give the data to the INN algorithm so that it can make decisions. So if you want to go world, to go commercial, this is a must. And in actual, there are some lists here, but this is the basic list that I can found for you, and one of the most I'm using for my work. Okay. So as I said before, computer vision. So by using camera, we have described this before. Using camera, okay, you focus on the object that you want to target. So let's say you want to target the crack on your bridge, the propagation of the cracks. And then after that, that images will be segmented out by using image processing algorithm. You try to segment out the crack only from the surrounding. Okay. And after that, you will use maybe a brain that has been designed before. You can use AlexNet, GoogleNet, whatever, to train the segmented image so that it can learn and you can detect whatever that you want. Maybe if let's say the image on the vehicle types, it can detect whether the vehicle is car, lorry, whatever. Maybe the people are working there, coming inside to the office, you can differentiate. This is engineers, this is carpenters, this is bar benders, whatever. the defects, as in my case. Okay, and after that, you store the data to the cloud storage, as I said, to make your work to be much more better in terms of data transferability, and you perform data analysis. So this one is good for the practitioners outside, because after you detect certain things, yeah, you want to report to the managers outside so that you can react. You can react to the administration. So if let's say you want to see the simulation, I will give you in terms of video after this. Okay. So this is one of the camera that has been installed in Singapore site, trying to detect the resources on the site. Can you see that? There is a bounding box, green and also red. The red bounding box displaying that or detecting that the person who are not using PPT. And the box also can also count how many persons there, and also count how many machines there, the bulldozer, whatever there, the excavator and so on. So this is good because it can increase the efficiency of the site resources. So maybe you need very minimum site people there to monitor. You just use a camera, the camera vision, as I said, computer vision, plus your ANN algorithm to perform monitoring. You can see that the person counted there, and it alerts if there are any PPE issues and so on. It's very, very handy. This is one application of in and on the civil engineering activities on site. Another thing is to perform truck arrival monitoring. This is very crucial because you want to monitor whether the right vehicle coming, and is it the truck coming at the right time, and what are the plate number of that vehicle. Is it correct? Because we don't want other people inside our site. So by using this, you can see that there is a virtual gate. Yeah? It's not a real gate, it's a virtual gate. When the vehicle passing, you can see that it is counting the number of cars or number of truck in and out, and will detect the license number and the truck counts. So it's very, very good to monitor it remotely by using ANN. So you don't have to be there, and you can enjoy your resting time maybe at your home while monitoring this. Even though I think you don't have to monitor it on it all, because there will be a report. There will be a report given like this on your mobile phone. On your mobile phone, you can see that there is a vehicle with a dump truck inside your site at this time, and the plate number is there, and the average load is 28, and it can be estimate the load per hour. So what is load for per hour for this car with this split? So imagine it's a very relaxation job without to go outside, and you just only sitting maybe at the beach, maybe while holiday, but you can do your work remotely by using this ANN technology. It's very, 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 very important. Very, very interesting. Okay. And another thing is like if you want to check your progress of your work at site, because at site from one floor to another floor, you want to know how many percent of the area have been installed the rebar, how much of the percent of the area have concrete, and where is the people there. So you can put a camera maybe on a certain level, maybe on the crane, and you may see that you will try to classify the with colors. So you can see that the orange color is the place where you put rebar. So this done by ANN, because ANN have the flexibility to classify. So you can get by time, how is the percentage? How much is the percentage of the rebar completion? Okay, so another applications of this technology, you can put the camera maybe at the top of the ceiling, and the helmet of your workers that is inside or outside to the office, you can put a kind of QR code, so that once the QR code is on the top of the camera, it can detect the type of the trades, because the people outside, inside the construction can be a carpenter, barbender, engineers, admin staff. So see, so can you see that? It can detect the trades, and you can know what is the time the people goes in and out from the office. You can see that. You can see there is a message there. There is in the yellow already. It's not so clear. So it's very good by using this. You can do this remotely by using camera. So maybe this kind of technology give a wake up to the lecturers in this university, maybe to invent this kind of innovation. You can commercialize it. So maybe this has been done globally, but why not to do it locally in Malaysia? Maybe no people doing it yet. I think during the COVID-19 2020, 18 March 2020, until sometimes recently, we have ended our COVID-19. So on that time, we have a problem to measure the distancing. Apa tu? Distancing 1 meter, 2 meter between one workers to another workers on site. So we can use NN to measure, to estimate the distance between them by camera. So can you see that? It's very, very interesting. So we can comply to the local authorities punya requirement lah. Whether they are working or not according to the distance lah. But I think not for the nowadays lah, because nowadays kita dah tak ada COVID and then have ended kan. So on that time we need that technology lah, so that the people on site can comply with the local authorities punya guideline, especially the distancing between the workers. Okay, this is also can be used on site. You can see whether the people are not following the social distancing guideline, and it is being colored by red color, the box, whereas the people which is more than 1 meter or 2 meters has been categorized by this green color. So it's very, very good for the people. So I think this application can be also done to see whether the right person on site, maybe the people is the person from outside, or maybe the people on the site is from outside organization. So you can do classification also, maybe by asking the workers to wear certain kind of wearing, so that the camera can detect and classify whether that wearing is fall under the organization people or the people which is outside from the organization. So maybe the practical training comes to the site, then the camera can distinguish, can differentiate. So it's good for the monitoring, monitoring for security and so on. Okay, that is all application of ANN during construction, before construction and in operation of construction. In actual, machine learning can also be used after construction, especially in my domain, to detect the defect. So maybe after you construct your building for certain years, the building facing some deteriorations, and we can use machine learning or this ANN to monitor, to check what are the status of that defect and the severity. Okay, so I give you one videos that has been taken from Philippines. The system has been developed, and please enjoy to see it.
Mac2 is the world's #1 artificial intelligence empowering the end-to-end process for the building and construction industry.
With the voice assistant and chatbot, Mac2 supports me anytime, anywhere. Hey 2, are there any activities overlapping with HVAC services in the schedule?
Yes, there is an intersection between HVAC duct systems.
So there is an interaction between BIM and also this
Show
technology.
the intersection from the BIM model. Please adjust the schedule to avoid overlapping.
Schedule is updated.
Thank you, Mac2. We can also ask Mac2 via chatbot to match the best building materials from the product catalog. Act 2 is not only giving the results, but also provides the analyzed report based on these results with price and quality conditions. With this intelligent outcome, the decision maker can easily decide the best products for the project.
MEC 2 is supporting the safety and quality inspection on site with smart guidance. Hey 2, I'm on the 3rd floor. Please show me the inspection checkpoint.
Hi, Sergey. Please follow the walkway for today's inspection.
Hey 2, Anderson Construction has to repaint the wall on 3rd floor, zone number 2. Add it to punch list with due date next Monday.
Issue added. Floor plan highlighted for Anderson Construction.
Hey 2, Walker Engineering has to fix window on the 3rd floor, room number 5. Add it to punch list, due date next Tuesday.
Issue added. Due date confirmed.
Hey 2, Walker Engineering has to cover electric duct in technical room on the 3rd floor. Add it to punch list with due date next Monday.
Done.
Empowered by mixed reality, MEC 2 can integrate the virtual model with the physical site for precise checking. Hey 2, did we purchase ventilation shaft covers for level 3?
Yes, we did.
Show me the details.
Please see on screen.
Okay, let's take a measurement. I see. There is a defect here. Add it to work list for Anderson Construction.
Defect added.
Thank you, MEC 2. Hey 2, can you call Tony?
Hi, Sergey. Can I help you?
Hi, Tony. Can you please check the power distribution box for this unit?
Yes, I'm checking from my data. This is the electric diagram. I'm sure this is an incorrect installation.
Yeah, I also think so. Thank you. Okay, see you tomorrow.
See you, Sergey.
Hey 2, create a defect for this AC unit and attach picture of power box to it.
Issue added and assigned to the electric department.
Thank you, MEC 2.
Okay, so I think most of you knows another application of civil engineering, which is for highway and traffic engineering, and most of you knows about this to classify the type of the vehicle on the intersections or along the roads, and so count the number of cars. So this is one of application for the traffic engineers. You can count the number of vehicles that you are interested on the certain roads, and you can determine the types. So this is good for you. I think this is for traffic counting, I think. And you can apply to the pedestrian if you want. You can extend the application to the another field, to the another applications. So this is for mechanical. I think mechanical, I don't think we want to do anything because we are talking about on the civil. Electrical also no one. Okay, this is the potential of in-end application in civil engineering. I think this is my last video, and enjoy it. Okay, that's it. I think from me. Thank you for your attention for this about 1:40 minutes. So I would like to receive any recommendations, any comments, or any question from the floor, and I will pass back to the moderator itself. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam. Thank you, Technology Syahrul Fithry, for an interesting talk. Now, if anyone has any question, I'm sure Technology Syahrul will be pleased to answer them. Is there any question from the audience? Actually, we have one question from the chat box.
Oh, is it?
Sir,
Okay.
from Dr. Asri.
Okay. May I read it? Let's say I develop a neural system for slope stability analysis. I train the system by running various slope stability conditions, such as the system can predict for the factor of safety of any slope. My question, can this system be used as a design tool for slope stability? I mean, does authority accept this approach? What is the professional body view on this? Thank you. Okay, this is a good application of, I think, in the geotechnical field, where you try to relate maybe you take some images on the slope stability and also relate with the safety factor. Okay? So I think can be used as a design tools is depending on your results, but can be used as a guideline, because there are a lot of factors that contribute to the factor of safety. So maybe due to the rainfall intensity, the soil types, and other factor that I could not list out here. So if that input covers the whole spectrum, okay, the whole spectrum, meaning the input data, then it can be as a design tools. But if let's say it just only cover part of it, then to be a design tool is in question. But can be used as a design, as a guideline only, guideline, so that if you face this kind of input, then you can predict the slope stability. So meaning that in order to make sure that you your system to be good, you have to study what are the main factors, what the whole factors that have the relationship with the factor of safety of the slope. So if let's say Dr. Muhammad Asri can list out the slope stability to me, then I can recommend whether this is to be a design tool or only as a guideline. Okay, thank you. Nabila Huda, I developed ANN for damage prediction for bridge, but how to install the algorithm that already trained? Okay, this is depending on your programming language facilities. If let's say you are using Python, you have different way to install the algorithm. In actual, there is no installation of algorithm. In my case, I'm using MATLAB. I have to know that algorithm content so that I can pass what are the passing argument to that algorithm. So remember, your algorithm is only outside code from the program. So you have to get that code and understand what are the inputs to that algorithm. Okay? So that we can pass the right thing from the MATLAB to that algorithm, so that the algorithm can train that damage prediction. Okay? So I'm using I use like that, because to get algorithm, usually if let's say in terms of toolbox, you need to purchase it. So you don't have to know nothing about the algorithm, you just only install it. So meaning that you have a money to buy that toolbox. Usually the cheapest one is to get that code, understand that code first, know what are the input variable. So we just call that program inside your MATLAB program, and we pass the right information, then we can use that as integrated. I think hopefully I have answered Nabila Huda. Another question, Muhammad Faiz. is that any method related to neural network that I can use if I have 10 to 20 data? So meaning that your data is limited lah, kan? Okay. There are a lot of research done how to make use on limited data so that you can have a significant model for your NN. One of the way is to you can call as cross validation, K cross validation. So maybe I type it. This is one method. Hopefully, Muhammad Faiz can see K cross validation. This is one way how you manipulate the data, even though it's very small, so that there is no question whether your model is accurate or not. So you can try to Google this and understand the theory of this cross validation because it's too lengthy here. It's dealing more on the statistical plus machine learning. Okay. Okay, welcome. No problem. Is there any question, or is it I not completely answer your question? One of the participants.
So any other question? Any point to raise?
So I just want to add, nowadays, I think nowadays, in my experience, nowadays, it is better now if you want to go commercial, use camera or other sensors than capture videos and images or sound, rather than numeric values. Because numeric values, you need people to collect it. Let's say if you have images, you have to transform it priorly to numeric. That is time consuming. So nowadays, the new NN direction is directly use image, videos, audios as input, and you get results. So the days that you use numeric data, I think is already traditional lah. You can use, but you still beginner lah. You still beginner. You can start as a numeric number. Just like in my case, using the what you call it, the concrete strength prediction. I'm using numbers. But for the invention that I've done in the exhibition, I'm using videos and images. Now I try to use audios because I have project now to use audios that can relate audios to the defect state. So that will be the next project that I will go in. So if anyone of the lecturers interested to join me, I'm welcome. I welcome. We can collaborate together to work on one project later, and we can form one special interest group if possible. That is the needs of nowadays. We collaborate one university to another university, rather than alone university.
So, sir, from your experience, is there any disadvantages you encounter using ANN software?
Can you rephrase again because I cannot get your question?
Is there any disadvantages that you have encountered?
Okay. Disadvantages in my case due to cost. Cost meaning that like this. I'm using MATLAB because MATLAB is a software that has been paid or purchased by UiTM. So some people using other languages such as Python, TensorFlow, Keras, Weka, which is what we call it, is a free source. There's no money to pay. So that is the advantage because money will be control your research, isn't it? So when you want to use that software as a commercial, then you need permission lah from your organization because that software is not yours. Unless you use Python free, so you can bring that thing. So that is my disadvantages. So meaning that I have to also to learn Python lah after this to make sure that my domain of accepting much more bigger. That is the thing that we face. Another thing is that the disadvantages is you have to know well your field. You have to know your field. So let's say for there's one research there by Dr. Muhammad Asri. I think you are expert in your field. So you have to know the correct input. You have to know the correct input, because incorrect input will make your modeling iteration much more longer. Okay, if you know the right input and there is a right correlation with the output, then your model much more faster to converge to the optimal model. So when I said optimal model, meaning that the error is very minimum. So to get that error which is very minimum is time consuming if you are not expert in your field to use the input in the NN research. Okay? So it doesn't matter how you understand NN. It's more on your field. You must master your field first. Then you use NN. You don't have to master NN the whole thing. You must master your field first. That is the disadvantage, depends on the person. So meaning that you have to collaborate expert people in your AN research on that field. Because especially when you do supervised learning needs expert people to decide first. Whereas unsupervised person, you don't have any expert. And most of the easiest problem is supervised. Unsupervised is very, very complex and is still unexplored generally. Some other people have started it, but more on the mathematical level. It's too abstract. And you don't need an expert. So that is the thing that I can highlight as the disadvantage of this method.
Okay, thank you, sir, for addressing this interesting topic. I think maybe there's no more question. On behalf of Civil Engineering and Technology, we would like to thank you for joining